Hi, welcome back to the channel. So in this video, we will see full wave rectifier, that is center tap full wave rectifier, right? So in the previous class, we have seen what is half wave rectifier in detail, definition of rectifier followed by how exactly the circuit diagram of half wave rectifier. Then we have seen what is going to be waveforms and what is with respect to the capacitive filter. Now in this we will see what is full wave rectifier and in detail about the construction of circuit diagram followed by the waveforms, same like the working like the half wave rectifier. Since we are having the drawback in the half wave rectifier that the even if you use the filter circuit, there is discharging time is going to be very lengthier one, and also the efficiency of a rectifier is only 40%. That efficiency derivation we will do later, but the performance and the efficiency is less in half wave rectifier because it is going to conduct only for the positive half cycle. Now we will see with respect to the full wave rectifier for the full cycle. So for that we will first write the circuit diagram. How the circuit diagram of full wave rectifier? Same, start writing the transformer with primary and secondary, right? So rectifying element diode. But here, since it is a full wave rectifier, how many diodes we should use? We should use two diodes, right? So we should use the two diodes. So it is same, input is AC, which is AC supply, positive, negative, primary N1, N2, right? Primary and secondary. So I will name this as diode number 1. I will mention this as diode number 2. Since it is consisting of two devices, full wave rectifier, and also we should write the load resistance here, and it is tapping the center of the transformer. So we should write it is tapping the center of the transformer, right? So here I will mention it as load resistance RL. So here we will measure what? We will measure VDC, that is V output, right? And the current through which passes, I will mention it as ID1. The current through which passes, I will mention it as ID2, right? So this is the circuit arrangement of, that is the full wave rectifier center tap. Then after that we will see the working operation. How exactly it works. So I will consider case number 1, right? What is case number 1? It is saying, case number 1 is saying for positive half cycle. For positive half cycle of input, how it works. So we will make here case number 1 and case number 2. Right? So positive half cycle means you are sending this positive half cycle to this circuit. What is going to happen for this circuit now? So we can rewrite this one more time as like the half wave rectifier. So here it is positive, here it is positive, right? So here it is negative, here it is negative. If it is positive half cycle of the input, so it is positive and negative. If it is positive, here it is positive and here it is negative, positive and negative. So here if it is positive, plus and plus, what is going to happen? Forward biased, and it becomes what type of circuit? Short circuit, and the diode D1 becomes what? On, and it conducts. What is the current which flows through this? ID1, right? Then what is going to happen here? It becomes minus, here it is minus, plus. What is it? Is reverse biasing. Reverse biasing means what type of circuit? Open circuit. Open circuit means diode D2 is off, through which the current ID2 will not pass, and that value is 0, right? So this, right? So here I should measure what? I should measure the load resistance RL, which is center tapping, right? So what is happening? How we should draw here is VDC. We should draw what is VDC, right? So diode D1 is on and diode D2 is off, and VDC, how we are getting? We are getting the VDC as like this. right? Here I will write VDC, and in this case diode D1 is on and the diode D2 is off for this positive cycle, right? So for the case number 2, I will write here only case number 2. What you are sending? You are sending the negative half cycle V in. If we are sending the negative half cycle, what is happening here now? It is minus, and this time it is plus. Here I will tell case number 2, it becomes minus and it becomes plus. If it is minus and plus, this acts as a open circuit. So it becomes a open circuit, right? What this one becomes a closed circuit, right? So here diode D1 is what? Off. What is diode D2? D2 is on, right? So everything else is same. It is VDC. So here VDC, how you are going to get VDC? So VDC you are getting for negative half cycle. In the negative half cycle, diode D2 is on, and what is the type of output you are getting is same. But here for this portion we should draw, right? So here what is that? Diode D1 is off, diode D2 is on. That is what the case is, right? So for positive cycle it is conducting, for negative cycle also it is conducting, but through the different diodes, right? So how to draw the waveforms for this? How to draw the waveforms for this is, so you can take the help of here the board, so that you will better understand if I take the waveforms, right? So can you guess how the waveforms now, if the two diodes are on, is, just look at now. Here first I will draw what is the input. What is the input? Like this, it is T. Positive, negative, positive, negative, right? So here the second one I will write what is VDC. For the case number 1, can I write now? For the case number 1, how we are going to get? For positive cycle, what is the type of output you got? We got the output like this. So it is case number 1, right? So right, so when it is for positive, we can write like this, right? So I will call this as here ID1. So what is the status of the diode? Diode D1 is on and diode D2 is off. It is VDC. Next we will take one more one, VDC. What is VDC? VDC current when ID2 is conducting for the negative cycle. For the negative cycle it is conducting, means for this cycle it is conducting. We should take like this. For negative only it is conducting, right? So for positive cycle this is the output, for negative cycle this is the output, right? Then together for both the cycle I should write now VDC for both the cycle. So combine these two and write, right? So this is VDC for full wave rectifier, right? So suppose I want to write IDC. IDC is also same. IDC is also same. Why? Why IDC is same? Because we know that V is directly proportional to I, Ohm's law. That's why IDC is same, right? So you can write this as VDC, this as IDC, right? Now after that, now the next question is whether we got what is the type of the waveform is DC? No. If it is not DC, what it is again impure form of DC. Now what best we can do is we can take the filter circuit for this. So we should take a filter circuit for full wave rectifier, so that we can improve this. So that the circuit arrangement will changes. How the circuit arrangement changes and the waveforms changes, we will see now, right? So here it is diode and here it is diode, right? This is, you can write capacitor, you can write the resistor, right? So here I will write it as VDC. This is C, this is RL, diode D1, diode D2, right? So everything else is same, everything whatever we have written same, but only thing is the capacitor C. We are focused more on this one. Where is that? This. So this combination is called as what? RC filter or filter circuit. We have just added the capacitor C, so that if the whatever the positive voltage you are given V in, what is going to happen at the time diode D1 becomes forward biased. Once it becomes forward biased, what is going to happen? The diode, it is connected to capacitor. Capacitor will start charging. Now it has, look, you can look this. It is going to charge up to this point 0 to A. It is going to charge. So what I will write is, so here from here we will write a sharp curve like this, right? Then after that, what is happening here now? It is decreasing. So decreasing up to which point? The decreasing is here, you can observe the decreasing up to this point, right? So here you can find out that point immediately here, right? So connect from here to here, right? So carefully observe this, here to here. But from here to here, what is happening? B to C, it is increasing. If it is increasing means we should write like this. Again here, that will go up to this stage. That's why we have written that, right? Then after that, what is happening? Again it is decreasing. So start writing. Again, capacitor charges, discharges, charges, discharges, right? So this type of arrangement, so we'll compare with the half-wave rectifier, how exactly we got in half-wave rectifier, how we are getting in full-wave rectifier, that we can see, so that you will understand, right? So look at this. In case of half-wave rectifier, your output is like this: charging, discharging, charging, discharging. You can observe here charging, discharging time. But what about the full-wave rectifier? The full-wave rectifier is like this. It is charging, discharging, charging, discharging, charging, discharging, right? So this type of waveform is less efficient compared to this type of waveform. So it is almost resembling it is almost approaching this constant value, so that it is we are able to get the purest form in case of the full wave rectifier center tap transformer. So that is the advantage of using the full wave rectifier, because of two things. The first thing is that this rectifier is able to perform its operation in both the half cycles. Advantage. What are the advantage? Both the half cycles. That's why it is going to conduct in both half cycles. Hence, what is going to happen? The efficiency or the performance increases. Increases how? By how much time? Doubles the half-wave rectifier. What is the efficiency of half-wave rectifier? Efficiency of half-wave rectifier is approximately, we can write it as 40.6%. Then what is going to be the efficiency of full-wave rectifier? We'll get approximately 81.2%. We'll prove this later. At this moment you can understand this half-wave rectifier is only 40. Now look at this double, because of the two diodes are going to be conducted in both the cycles. So that is a advantage of full-wave rectifier. If you use what type of transformer? Center tap transformer. It is tapping at the center of the transformer. That's why it is center tap transformer. Obviously it is step down transformer, right? We will see in the next video what is full-wave rectifier with respect to bridge rectifier, and the difference between the full-wave rectifier center tap and the bridge. That we will see in the next class. Stay tuned to this channel, click on the bell icon. These are the topics which are going to be covered in the introduction to electronics or the basic electronics of first year. Thank you. The electrical sections also. We'll see in the next video.